Hello grade 9 students, last time we discussed all about direct variation where the equation is y equals kx and the graph is a straight line that passes through the origin. So this time we'll learn also another type of variation which is called the inverse variation. First, let us have a warm up here. Find f of -4, f of 0, and f of 3 for each quadratic function. Number 1, just substitute -4, 0, and 3 to x. What's your answer for number 1? 24 and 13. So if f is -4, 16 plus 4, 20. 0 plus 4, 4. 9 plus 4, 13. How about here? Number 2. f of x equals 1/4 x squared. 4, 0, 9 fourths. 16 divided by 4, 4. 0 divided by 4, 0. 9 divided by 4, 9 fourths. And how about here? Number 3. f of x equals 2x squared minus x plus 3. Answer is 2 times 16, 32, plus 4, 36 plus 3, 39, 3, 18. Okay. Pag 0 naman dito, 3. Si 0 na yan. Pag 3 to 9 times 2, 18 minus 3, 15 plus 3, 18. Problem of the day, use the digits 1 to 8 to fill in 3 pairs of values in the table of the direct variation function. Use each digit exactly once. The 2 and 3 have already been used. Okay, yep. 1, 2, 3, 4, 5, 6, 7, 8. Okay. All the digits 1 to 8 were filled up in this table, right? Okay. Now, in this topic, we will learn how to recognize inverse variation by graphing tables of data. So, vocabulary inverse variation. It is a relationship in which one variable quantity increases as another variable quantity decreases. The product of the variable is a constant. So, like in direct variation, the product of the variable is a constant. Right. And as x increases, y decreases this time. So it's different from direct variation. So in direct variation, as x increases, y increases also. But in inverse variation, as x increases, y decreases. So in numbers, in variation, this is how we describe y equals 120, y equals 120 over x. So in direct variation, we have y equals kx. So this time in inverse variation, we're going to divide the constant of variation by x. So y equals k over x. Yun, dito. It's equivalent to y equals k over x. And if we're going to solve for k, the concept of variation, we'll just multiply the variables x and y. Okay. So let us now have here our first example. Identify inverse variation. Determine whether the relationship is an inverse variation. The table shows how 24 cookies can be divided equally among different numbers of students. So if there are two number of students, the number of cookies is 12. If there are 3 students, 8 cookies. 4 students, 6 cookies. 6 students, 4 cookies. 8 students, 3 cookies. So as you can see, as x increases here, 2, 3, 4, 6, 8, the number of cookies decreases. 12, 8, 6, 4, 3. Right, so this is an example of an inverse variation. And to solve for the constant of variation, we'll just multiply x and y. Okay, this is different from direct variation, because in direct variation we will divide y by x, but in inverse variation we will multiply x and y. So 2 times 12, 3 times 8, 4 times 6, 6 times 4, 8 times 3 are all equal to 24. So 24 is now what we call the constant of variation, and our equation is xy is equal to 24, or y equals 24 over x. Yes. So y equals 24 over x, our constant I mean the equation of variation where k is 24. This is the equation of variation for the inverse variation. So helpful hint: to determine if a relationship is an inverse function, check if the product of x and y is always the same number. Okay. Another table. As x increases, as x increases, y also increases. So this is not an inverse. This is not an inverse. This is not an inverse variation, because even if you do not solve for the constant of variation, even if you don't multiply x and y here, you cannot tell whether it's an inverse variation or not by looking if x increases or as y decreases. So in this case, y increases, y also increases. So this is not an inverse variation. The relationship is not an inverse variation. How about here? Determine whether the relationship is an inverse variation. As x decreases, y increases. Okay, now if we multiply the x and y, 60, 60, 60, 60, 60. Okay, it has a constant. The constant of variation is always the same. So the product of x and y is always the same. xy equals 60. Therefore, 60 is the constant of variation, and the equation of variation is y equals 60 over x. So the relationship is an inverse variation. How about this? Sample 1b. Determine whether the relationship is an inverse variation. As x, wait, what's this? Alright, 42186. Okay, the numbers are rumbled in each coordinate. So let's just determine if the product of x and y is the same. 2 times 4, 8. 4 times 2, 8. 8 times 1, 8. 1 times 8. But 2 times 6 is 12. So this is not, the relationship is not an inverse variation. Sample 2a, graphing inverse variation. Okay, let's create a table, then graph the inverse variation function. So for x values, you have negative 4, negative 2, negative 1, negative 1 half, negative 1 half, 1, 2, 4. And substitute y here in the function y equals 4 over x. So I just divide 4 by x, negative 1, 4 divided by negative 2, negative 2, 4 divided by negative 1, negative 4, 4 divided by negative 1 half, negative 8, 4 divided by 1 half, 8, 4 over x, 4 divided by 1, 4, 4 divided by 2, 4 divided by 4, 1. Okay, we're now ready to plot the points. Let us determine. Okay, negative 4, negative 4, negative 1, negative 2, negative 2, negative 1, negative 4, 1 of 8, 1, 4, 2, 2, 4, 1. Connecting the points. Okay, we have two smooth curves. So in direct variation, the graph is a straight line that passes through the origin. But in inverse variation, the graph is two smooth curves. It's represented by two smooth curves here. Yes. Another, f of x or y equals negative 1 over x. Okay. Let's try to assign values of x, then solve for y. Y is actually the f of x. So divide negative 1 by negative 3. Negative 1 divided by negative 2, 1 half. Negative 1 divided by negative 1. Negative 1 divided by negative 1 half, 2. Negative 1 divided by 1 half, negative 2. Negative 1 divided by 1, negative 1. Negative 1 divided by 2, negative 1 half, and then negative 1 third. Plotting the points. Yan. Yan yung graph ng inverse variation. Graph of inverse variation is represented by two smooth curves. Another, y equals negative 4 over x. Yeah, let us solve. Divide negative 4 by x. Ayan. yung answer. Negative 4 divided by 2 is negative 2. Negative 4 divided by 4 is negative 1. Negative 4 divided by negative 1 is positive 8. Then plotting the points, plotting and connecting the points. So the graph inverse variation is represented by two smooth curves. Next, create a table, then graph the inverse variation function. F of x equals to 8 over x. 8 divided by the assigned values of x here. Yan. 8 divided by negative 1, negative 8. 8 divided by 2, 4. 8 divided by 4, 2. 8 divided by negative 8, negative 1. So, yun. So, always remember the graph of an inverse variation is represented by two smooth graphs, two smooth curves, should say. And yung sa direct variation is represented by a straight line that passes through the origin. Here. Application. Let us learn also how to solve word problems that involves inverse variation. So, as the pressure in the gas and a balloon changes, the volume of the gas changes. Find the inverse variation function and use it to find the resulting volume when the pressure is 30 pounds per inch square. So our x values here is pressure in pound per inch square, and the y values is volume. So let's determine the constant of variation by multiplying x and y. 300 times 5 is 1,500, 1,500. So you can see that the constant of variation is 1,500. So our equation is y equals k over x, so y equals 1,500 over x. Now let us solve here. Find the result, find v, find the volume, meaning we're going to find y. So to find y, we just divide 1/5 by x, the pressure, which is 30. 1,500 divided by 30 is 50 cubic inches. Okay, that will be the volume of the gas if the pressure of the gas is 30 pounds per inch squared. Next, example 3. An 8th grade class is renting a bus for a field trip. The more students participating, the less each student will have to pay. Find the inverse variation function and use it to find the amount of money each student will have to pay if 50 students participate. So you can see in the table, as students increases, the number of students increases, the cost decreases, yes, for each student. For 10 students, 20. For 20 students, 10 na lang. For 25 students, 8 pesos or dollars. 40 students, 5. So this is an example of an inverse variation. What's the constant? Just multiply x and y. X students, cost is y. 10 times 20, 200. 20 times 10, 200. 25 times 8, 200. 40 times 5, 200. 200 is the constant of variation, and therefore the equation of variation is y equals k over x, or y equals 200x. Now the question is, okay, find the amount of money each student will have to pay if 50 students participate. Okay, so the student is y. So we're trying to solve for x here. Cost. Wait. 50 students. Wait. Why? We're trying to find here why the cost to pay for 50 students to participate. So we'll just divide 200 by 50. Is $4 only. Okay. $4 or 4 pesos. You know. So let's now have here our lesson quiz part 1. Tell whether each relationship is an inverse variation. For number 1, what do you think? 545, 15, 15, 25, 9, 75, 3. Yes. We multiply x and y. It will multiply x and y for each coordinates here. It will result with the same constant of variation. How about here? 625, 400. No, I think no. No, because the constant of variation. Multiply x and y, they're not the same. Let us graph y equals 1 over 4x, or y equals 1 over 4x. Okay, that's the graph. So That ends our lesson on inverse variation. So I'll see you next time again. Goodbye and be good. Take care.